Good afternoon, my YouTube viewers. Crystal here. I'm just here this afternoon because I wanted to make you another video. I've noticed that the videos where I do the code reviews get watched, but the videos where I promote my blog posts don't get watched. But the thing is, it's like if you want to get the code for this code review, then you really do need to watch the blog post. But what I'm going to do is I'm going to go ahead and do a code review. This code review is on the Shampoo data set that I got off of Jason Brownlee's site. And it's a data set for shampoo prices dating back from 1901 to 1903. And so I decided to use that as an example. And in this particular program, I decided to use statsmodels. Statsmodels is a library, Python library that deals mainly with statistics, and it's different to work with than sklearn. I have to say that I like sklearn better because sklearn is easier to work with than statsmodels. But if you're a statistician, then I guess you would like statsmodels because it's got all of these statistical functions that you're not going to see on sklearn. So I know that I do need to become more proficient in statsmodels, and I hope that I do become more proficient as I carry on working with data science. So what we'll do now is we'll go ahead and go over the code review. I've saved my code review onto my personal GitHub account. So if you want to get the code for this, then you will need to read the blog post. And in the blog post, I will give you the code. So I wrote the program in Google Colab. Google Colab is a free online Jupyter notebook. It has Python already installed, and it has lots of Python libraries already installed on it as well. So the only thing that you need to do is import them. So after I created my program in Google Colab, I imported my libraries, and so I imported pandas and numpy and matplotlib to start with. And then I loaded my CSV file. The CSV file I got off of Jason Brownlee's site. And what Jason Brownlee did was when he used the data set, he used the month as the index, but I didn't want to use the month as the index. So where it says index underscore call, I just left that as a comment, just to let you know that you can use that to make the month as an index if you want to, but I didn't want to. So now we're looking at the data set, which we called series. Has 36 months of data. And now we're looking at the info. So the month is a date times 64, and sales is a float 64. I checked for any null values, and in this instance, there were no null values that needed to be imputed. And then what I did was I put the data onto a graph and plotted it on a scatter plot, and you can see that as time went on, the price is increased. So now what we're going to do is we're going to define the training and validation dates. So the first thing we had to do is we had to take the month and we had to convert it to a string. So that made it an object. So if you look, and then when we check the info, you can see that the month is now an object instead of a timestamp. What was it? What did they call it? Date times 64. So now it's an object. And then what we did was we time stamped the date. And so now we've got like month, sales, and then timestamp. So after we timestamped it, what we wanted to do is we wanted to separate the data set out for training and validation. So the training set was 1901, 0101 to 1903, 0730, and valid was 1903, 0801 to 1903, 1231. So now you can see the train set, and then you can see the valid set. So the valid set, we have 1, 2, 3, 4, 5 rows of data. And now what we did was we plotted another graph so you can see that the train data is in blue and the valid data is in amber. The next thing, now what we've done is we decided to use the naive approach to forecast the data, and you see that the naive approach just gave you a straight line. And on this straight line, you had an RMS of 10,940. So that was more than the neural network, which we did the other day. We put it on a data frame so you can see on the data frame, and it was just a straight line. All of the predictions were the same. And the next thing we did was we did something called auto regression. And when we did auto regression, you can see the auto regression here. The auto regression is not very much like the actual valid. And the RMS was 7962. So your auto regression was 7962. So that is actually less than the naive. Let's look over here. Yep, it's less than the naive, and it looks a bit unusual, but it's less than the naive. So that's 7962. So you have to keep a mental note of this. 7962 is so far the lowest, and 7962 I believe was actually less than the neural network as well. Now what we're going to do is we're going to check moving averages. And you can see, you can look at moving average, and that's not anything at all like the valid. And the RMS, or the mean squared error, was 87,454. So that was just like way off the mark. So you know that we're not going to be using moving average. Moving average is not suitable for this example. Next thing we're going to check is simple exponential smoothing. Simple exponential smoothing is, again, just a straight line. And you had an error of 12,593. So this error was definitely more than the auto regression, and I believe it was more than the naive. Next thing we're going to check is Holt-Winter's exponential smoothing. And that's just a straight line as well. And your error was 22,185. So again, that's more than a lot of the others. So with regard to stats models, the winner was let's just look and see. The winner was auto regression because it was 7962, and I do believe that the error was actually better than the error on the neural network, because the program that I wrote before this program was the neural network one, and I don't remember exactly what the error was, but if you read my blog post that I'm currently working on, I'll include the error of the neural network along with the error of random forest and linear regression, so you can compare the errors of all the different models and decide which model is best. So that concludes this presentation. I hope you like it. I made it just for my YouTube viewers because I have noticed that they will read they will watch the videos if I give a code demonstration, but they don't necessarily watch the videos when I let you know that I've made a blog post. But if you want to get the code for this program, then you need to actually read the blog post because I've got the code in the blog post. So if you like my video, please like, subscribe, and share. If you want to keep receiving videos and you want to be notified whenever I make a video, then please press the bell button beside the subscribe button, and every time I make a video, you will receive a notification. If you like the work I do and want to make a donation, I've got my email address to my PayPal account in the description box down below. And thank you so much for watching this video, and I look forward to making more videos for you in the future.